Like many of you, I got into geology by finding fossils. I would go down to the beach near where I grew up and I would scour the rocks for treasures like this beautiful ammonite. But what actually are fossils? Let's find out. Pew! Hi, welcome to the show where I teach you how to read the secrets of geology that are written in the rocks. In this episode, we're going to start off by defining what a fossil actually is, and then we're going to look at the different types of fossil that you might be able to find when you go out and look at rocks yourself. Originally, the term fossil meant anything that was dug up out of the ground, and that could be bits of organic matter, the remains of living things, but just as likely to be bits of pottery or stonework and things that humans had made. As the science of geology and paleontology, which is a specific study of fossils, developed, the term fossil came to mean the remains of living organisms that were preserved in the rock record. Living organisms can include animals, plants, fungus, bacteria, microbes, anything that's alive. The kinds of fossils that people are mostly going to be familiar with are going to be stuff like dinosaur bones or shells. And those are the hard parts of the organism. Those are the bits that are most easily preserved when an organism dies. That includes things like the ammonite that I showed you earlier, and things like this hefty trilobite. Look at the size of it. That's only part of it, about this long. Huge, chunky. Things like this have hard mineralized shells and they live on the seabed, so it's pretty easy for them, relatively speaking, to get fossilized after death. Bones and teeth are also quite hard, so tend to fossilize relatively well. And that's things like this ichthyosaur vertebrate. This one's from the Triassic period from southwest England. So that ichthyosaur vertebrate was just one single piece of the ichthyosaur. And that's mostly what you tend to find, broken up bits. Things like that large bit of trilobite and the full ammonite shell are often quite rare. Mostly what you're going to find is chewed up bits of shell like this beautiful piece of Silurian Wenlock limestone. It's chock full of all of these bits of shells that would have been chewed up and stirred about on the seabed and broken up. This is a little slice of the Silurian seabed from 420 million years ago. But even things like the Wenlock limestone are still relatively well preserved and rare compared to the vast majority of fossils that you're likely to find in the rock record. Mostly, it's going to be isolated tiny chunks of shell or bone. There's a specific reason for that, and we'll talk about it in detail in another episode. So whilst it is relatively easier to fossilise the hard parts of an organism, there are rare instances where soft parts do preserve. One of the most famous examples of soft part preservation is undoubtedly the Burgess Shale. It's an early Cambrian deposit found in northwest Canada and is world famous for having preserved the soft parts of animals, things like the gills and the eyes and the stomach contents. Imagine how cool it is to be able to see the stomach contents, the last thing a creature ate 512 million years ago, just before it died and was preserved. Soft part preservation is exceptionally rare, so don't be too disheartened when you go out looking for fossils and all you can find is hard parts. That's what it's like for most of us. And that's why the fossil record probably only counts for a couple of % of all of the organisms that have ever lived on Earth, if we're being generous. When we find the parts of an animal, whether it's soft parts or hard parts, we call this a body fossil because it's a direct fossilization of part of an organism's body, whether it's a plant or an animal. But those aren't the only kinds of fossils we can find, so let's look at some more types. Probably the most common fossil to find in sedimentary rocks is trace fossils. These aren't the remains of an organism's physical body, they're actually traces of an organism's behaviour. That might sound a bit strange, but you must have heard of dinosaur footprints. Well, it's not just dinosaurs that leave trace fossils, or footprints for that matter. Organisms have been leaving trace fossils as long as there have been organisms on Earth. A nice example is this pipe rock from Norway. This is about 500 and odd million years old, and these round circles that I'm pointing at are the tops of tubes left by marine invertebrates, maybe worms, digging down into the sediment. Bit of a more spectacular example is this Jurassic Thalassinoides trace, and that's this tube here, the preserved trace of a crustacean digging its way through a calcareous seabed. Again, maybe he's looking for food, maybe he's looking for shelter, looking to escape predators. It's the remains of an animal's behaviour. It's like a little glimpse back in time. You can almost, if you listen carefully, hear the scuttling sound of it clicking its way through the seabed, digging away and chewing at the rocks. Some people find these less exciting than body fossils, but I think they're just as cool. You can just imagine this little creature digging its way through the seabed, chomping away on bits of organic matter, scratching away with its legs, and in some places you can actually still see the scratch marks left by the legs. It's like if you'd been there just a little bit earlier, maybe you'd have been able to see the animal doing its business. But instead we just get left with this trace of its little home and what it was doing on its day-to-day life 165 million years ago. Another incredibly common type of fossil, but one you may never have even seen, even if it was there, are microfossils. Some creatures that make shells and have hard parts are absolutely tiny, like these foraminifera. But it's not just foraminifera that make microfossils. Radiolaria, diatoms, all kinds of beautiful microscopic organisms leave hard parts that can not just be preserved in rocks, but actually can form rocks themselves. The White Cliffs of Dover, the white chalk iconic cliffs, they're made of the bodies of billions and trillions of tiny algae that had little calcareous shells. And that chalk is found all over the world in Cretaceous and Eocene rocks. So they can have a huge impact on the geological record and even the climate. Think how much carbon it took out of the atmosphere to make all of those little shells. Another type of microfossil are organic walled microfossils. Some microorganisms don't have hard shelly parts like diatoms and forams do, but they have a very resistant cuticle, kind of similar to your nails or your skin, and that preserves quite nicely as well. A lot of these organisms are referred to as acritarchs, which is a technical term for we don't actually know what this is, we just know that it was alive at some point. Another really common type of microfossils are conodonts. These are little tiny little teeth-like structures that belonged to a conodont creature, which is kind of like a very primitive vertebrate. Our final fossils are ones that I can't even show you examples of in my hands because they're just too small, and that's molecular fossils. And these come in two broad forms: biomarkers and colour pigments. Biomarkers are distinctive biologically produced molecules that belong to specific types of microorganisms, and by looking at biomarkers we can see which microorganisms were alive when the rock was sediment, and sometimes we can even tell what kinds of metabolisms those organisms were using. Sometimes, in very rare cases, colour pigments can be preserved, and with a little bit of scientific magic we can work out what colours they were before they were altered by the fossilization process, and work out things like what colour the feathers of dinosaurs or beetle carapaces were. Now we get to the contentious topic of pseudofossils. These are things that look like they might have been living organisms, but probably weren't, even if in some cases they did have the involvement of living organisms in their formation. Nice example of that is this oncoid. It has this stromatolitic texture inside. So this is an abiotic structure made by carbonate rolling around on the seafloor. But it certainly looks like something that might have been grown by a living organism. And in fact, microorganisms are involved in the growth of these, but they're not made by the microorganism on purpose. Some of the cooler examples are this carbonate and pyrite nodule, formed by chemical reactions within the sediment after the sediment had been buried and started to be compacted. Look what it looks like inside. It's easy to see how someone might think that that was a fossil. And there might have actually been a fossil at the centre of it that was the nucleation point for the chemical reactions that produced this, but this is an entirely abiotic structure. A really cool one is this differential weathering from a sandstone. Sandstone had lots of iron in it, and when fluids passed through it, the iron oxide was dissolved and reprecipitated out through cracks in the rock, and then the sand and mudstone was weathered away to produce this honeycomb weathering structure. This is a pretty extreme example, but this is really common, and it's pretty easy to see how someone might look at this and think, oh, that's a coral or a sponge or something, but it's definitely an abiotic structure formed by the precipitation of oxides. And then what about this? If you saw this and you didn't know, I bet you'd think it was a plant, like a seaweed or a fern, but this is manganese dendrites. Manganese oxides precipitating out through the sandstone, and they form this beautiful fractal pattern that looks like fern leaves. Absolutely incredible. But again, very common, completely abiotic, and happens after the sediment's been buried and is turning into stone. There we go. Thanks for watching. I hope you've enjoyed this as much as I have. Hopefully by now you've got a much better idea about what is and what isn't a fossil, and the different kinds of fossils that you can find. What we'll do next time is look at the actual preservation of fossils and how fossils are formed, because understanding how fossils are formed will help us when we want to go and look for fossils as well. Thanks very much for watching. If you've liked the video, subscribe, give it a thumbs up, share it with your friends on social media, and leave me a comment below to tell me what you thought. Have you found any cool fossils or pseudo-fossils or sedimentary structures or mysterious things in rocks that you're not sure what they are? Leave a comment below and tell me what you found. Or tag me on Twitter or Instagram at geology_Johnson, or come and find me on Facebook at facebook.com/idigfossils. Do you see what I did there? Until next time, take care, thanks for watching, bye bye.